Okay, these are the video worked solutions for the Year 7 Perimeter and Area preparation test. Okay, you can use a calculator in this test. 30 minutes is allowed and you need to show all necessary working in the spaces provided. First question, insert the appropriate unit. You are to choose from millimeters, centimeters, meters or kilometers. First one, the length of Ashfield swimming pool. Sorry, that shouldn't be there. So the length of Ashfield swimming pool is 50 meters. You can just put the M or you can write the word meters. The thickness of a ruler. So we're not talking about the length or the width of a ruler. We're talking about how thick a ruler is, and that would be 1 millimeter. Okay, because a ruler is quite thin. And the height of your desk, choosing between millimeters, centimeters, meters or kilometers, that would be 70 centimeters. Now, question 2. Find the perimeter for the shapes below. Remember, perimeter is the distance around the shape. So you could do 5 times 4 because each of these is 5. So it's either you can do 5 times 4, which is 20 centimeters, or you can do that the perimeter is 5 plus 5 plus 5 plus 5, which is also 20 centimeters. So you could do that either way. With the next shape, we've got a rectangle. Remember that opposite sides are equal in length. So we've got 8, 8, 4, and 4. So the perimeter is 8 plus 4 plus 8 plus 4, which is 12 plus another 12, which is 24 centimeters. You might want to also write it as, or you could write it as 2 lots of 8. So it's 2 lots of 8 and 2 lots of 4 if you want, which again is 24. As long as you're adding up the 4 sides, it's fine. I often do 8 plus 8 and then 4 plus 4 and add those 2 answers together as well. Now our next shape here is a parallelogram. 2 pairs of opposite sides, equal in length and parallel. So if this distance here is 16, so is this distance, the opposite side is 16, this one is 10 and so is that. And so the perimeter is 16 plus 10 plus another 16 plus 10. Now you can, there's lots of ways you can add this up. 16 and 16 is 32 and 20 is 52. Or you can do 16 and 10 is 26 and 26 and 26 is 52 meters. Either way would be fine. This next shape, remember the equal markings here. This side is 4 centimeters, so is this side. This is a trapezium, and so the perimeter will just be 6 plus 4 plus 8 plus 4, which is 10, 18, 22 centimeters. Okay, we'll go to the next page. Okay, here is question 3. Convert between the following units of length. You can use the flow chart, or you can use conversion of units that you know. For example, we know that 1 centimeter is 10 millimeters for the first one. And so therefore, when you're converting from centimeters to millimeters, you'll multiply by 10. So, or you can use the conversion chart. So going from centimeters to millimeters, if you follow the arrow, you'd multiply by 10. So it's going to be 5.5 times 10. Remember, you can use a calculator for this. So 5.5 times 10 is 55 millimeters. In the next question, we're going from meters to kilometers. If you use the conversion chart, you need to divide by 1,000. So that would be 15,000 divided by 1,000, which is 15 kilometers. Now, the other way you can do this is just to write the conversion down. We know that 1,000 meters is a kilometer. We can also see that when you're converting from meters to kilometers, you'll get a smaller answer. So therefore, you've got more meters than kilometers, so that's why you would divide to work out how many kilometers you've got. And we divide by 1,000 because 1,000 meters is 1 kilometer. In the next question, we know that 100 centimeters equals 1 meter. So to go from centimeters to meters, we can see we've got less meters than centimeters. You would divide by 100, or just using the chart here, from centimeters to meters, we divide by 100. 165 divided by 100 is 1.65 meters. Now, of course, you can use a calculator to do this. And in the last question, meters to millimeters, we know that 1 meter is 1,000 millimeters, or we use the conversion chart from meters to millimeters. If you follow this, you need to times by 100 and then times by 10. So we can do 4.7 times 100 times 10, and or you can just times by 1,000 in one go. So you would get 4,700 millimeters. Okay, now, so I would you can just use a calculator for this. The other thing you can do, every time you multiply by 10 or 100 or whatever, you're moving the decimal place to the right. So if I multiply by 100, I move it 2 places to the right. If I multiply by another 10, I move the decimal point another 1 place to the right. So you get 4,700. But because we haven't done decimals yet, I would like you to just use your calculator and do 4.7 times 100 times 10. Now question 4 says to find the perimeter for this shape. It says hint, make sure that the units are the same. So we've got 25 centimeters and we've got 1.5 meters. So you could do this question 2 different ways. What we'll do, we'll convert the meters into centimeters. So 1.5 meters, if we're going from meters to centimeters, we times by 100. Also, we can just write the rule that 1 meter is 100 centimeters. So therefore, if you're going from meters to centimeters, you're going to end up with a larger number and basically 100 times bigger number than what you've got in meters. So 1.5 meters is 1.5 times 100, which is 150 centimeters. So therefore, the perimeter will be 150 centimeters plus 25 centimeters plus 150 plus another 25. Now 150 and 150 is 300, 300 and another 50 is 350 centimeters. That's one way of doing this. The other way to do the question would be to convert everything to meters. Or the other way we could do it is to say 25 centimeters is, so to go from centimeters to meters, you've got less meters than centimeters, you would divide by 100. So we get 25 divided by 100 meters, which is 0.25 meters. So the other way we could have done this perimeter question is to give the answer in meters. So you would have 1.5 plus 0.25 plus 1.5 plus 0.25 meters, which is 1.5 and 1.5 is 3, and 0.25 and 0.25 is 1/2, so it would be 3.5 meters. Now, you obviously can see that it's very, very important to put your units in. If you just write 350 but don't write units, you won't get full marks for this question. If you write 3.5 and don't put that the units are meters, you won't get full marks for that question. So it's really important that when you do state quantities that you need to put the units, because obviously 350 and 3.5 are different. And 350 centimeters is different to 350 meters, just like 3.5 meters is different to 3.5 centimeters. So when using lengths, you must state units. Okay. Now in this question, it says to find the length of the missing side with the question mark, and then find the perimeter. Now what I'm going to do, we know that this length here is 5. So that's the vertical line there, that's 5. So what is the same distance as that line? It would be this little 2 and this one. So that 2 plus that question mark, if I slide this 2 across and put it down there, those 2 add up to 5. So therefore, the question mark is 3 meters. So you'll get 1 mark for that. So once we know that that's 3 meters, then we can say, we can work out the perimeter. So the perimeter, I'll start with the 4. 4 plus 5 plus 9 plus 2 plus 5 plus 3. You might want to put a dot where you're starting, so that, or tick them off as you go around so that you don't miss a length. Remember, that's all in centimeters. So 4 and 5 is 9. Remember, you do have a calculator, but sometimes it's easier to do them in your head. So 4 and 5 is, is 9, 9 and 9 is 18, 18 and 2 is 20, and another 8 is 28. Actually, it's not centimetres, it's actually metres. So just be very careful, I made a little mistake there. Answer's 28 metres. Okay, now for the next question. It says, find the area of the following shapes using these formulas. Now this is a square with 4 equal sides, so therefore area is s squared. That means side length squared. So it's 5 squared, or 5 times 5. So it's 5 squared, which means 5 times 5. Remember, when you do the area of a square or a rectangle, it's one length times the other one. So side times side. So 5 times 5 is 25. And you must put units because it's 5 centimetres times 5 centimetres, and centimetres times centimetres is centimetres squared. With this next one, area of a rectangle is LB, which means length times breadth. Okay, so therefore it's 8 centimetres times 4 centimetres, which is 32. And if you multiply centimetres by centimetres, you get centimetres squared. Because it's really important to put your units. Okay, so centimetres times centimetres, we get centimetres squared. So whenever you're doing area, you should be getting square units. The next question, now this is a parallelogram, okay? So area is base times perpendicular height. This one up here, BH. So it means base times perpendicular height, which is, now the base, that length and that length is 16. Remember, base and perpendicular height must be at right angles to each other. So it's going to be 16 times 8, not 16 times 10. So just be careful with that. And 16 times 8 is 128 metres squared. Okay, the next question is find the area of this triangle. Now on our formula sheet, we've got area of a triangle is half BH, and that means area is a half times B times H. Now in this question here, the base is 8 and the height is 5. Again, remembering that base and height must be at right angles to each other, and they are. So it's a half of 8 times 5. These are centimetres and centimetres. So a half of 8 is 4. 4 times 5 is 20 centimetres squared. Next question, this is another triangle. So area is a half times B times H, or half times base times perpendicular height. Again, base and perpendicular height must be at right angles to each other. So the B, the base is 6, and the height, this is the height, is 7. So it's a half times 6 centimetres times 7 centimetres. And a half of 6 is 3, and 3 times 7 is 21. Again, units of area are centimetres, squared units, so centimetres squared in this case. With the last triangle here, again, area is half times base times height. Our base is here, which is 8 metres, and we don't want a slant height. We want the perpendicular height. See, we've got a right angle here, and this is our perpendicular height. So how tall is this triangle? And it's 6 metres tall. So it's a half times 8 metres times 6 metres. A half of 8 is 4. 4 times 6 is 24 metres squared. Now, converting area units. What is an appropriate unit used to measure the following areas? Now, the area of a suburb. Now, we know that the area of a suburb, it would be kilometres by kilometres. So the area of a suburb would be kilometres squared. Now, the area of your classroom. Your classrooms are probably about 6, I'm not sure how many metres long, could be 6, 7 metres long. So it would be definitely metres by metres. So therefore, if you're doing a metre length by another metre length, you end up with metres squared. And the area of this A4 page. Now an A4 page is approximately, I think it's about 21 centimetres across, and I think it's nearly 30 centimetres down. So it's centimetres times centimetres, which will give us centimetres squared. Now for question 7, to calculate the area of these composite figures. When you're doing composite figures such as this one, you need to divide the shape up. So you can either decide to draw a line across or a line down. I'm going to draw a line down. So I've got area 1, and area 2. So I like to draw them separately. So here is my area 1, and I like to get my pen around it so that I can see definitely how long that is. It's 2, and this length here is 8. So the first one is 2 by 8. So the area of this is 2 meters times 8 meters, which is 16 meters squared. That is area number 1. Now my second area is this one here. Now you need to be very careful here. This is 2, but this length all the way across there is 12. Now if this bit here is 2, then 2 plus this bit here has to equal 12. So this bit is 12 minus 2, which is 10 meters. So area 2 is 2 times 10. So 2 times 10. Okay, it's not all the way across like that. It's 2 times 10. So this area is 2 meters times 10 meters, which is 20 meters squared. So therefore the total area of the composite figure, composite figures are figures made up of 2 or more shapes. It's 16 meters squared plus 20 meters squared is 36 meters squared. Okay, now for the next question to calculate the shaded area. Now the way you would get that shaded area is you would have a rectangle and you would cut the triangle out of it. So you need to work out the area of the rectangle first and then the area of the triangle. And then you're going to subtract those areas. So the rectangle is 12 meters by 16 meters. So its area is 16 meters times 12 meters, and 16 times 12 is 192, and that would be meters squared. Then we look at our triangle, and the base of this triangle is 10 meters and the height is 8 meters. So the area of a triangle, the formula is a half times base times perpendicular height. So again, our base is 10 and our perpendicular height is 8. So it's a half of 10 is 5. 5 times 8 is 40 meters squared. Now, because this over the shaded area is the rectangle with the triangle cut out, therefore the shaded area will be 192 meters squared, take away 40 meters squared, which is 152 meters squared. Okay, now in this last question, we're converting between metric units of area. To do this, you can just use the flow chart as you did for length, or you can do the actual conversions. So the first one, we're going from centimeters squared to meters squared. So to go from centimeters squared to meters squared, you would times by 100. So it's 5.5 times 100, which is 550 millimeters squared. So that's your answer for the first one. The other way you can do it is write down the normal conversion for centimeters to meters. We know that centimeters to millimeters. We know that 1 centimeter is 10 millimeters. So therefore, if you're doing centimeters squared, you need to do the conversion twice. So normally, when you do convert from centimeters to millimeters, you do 5.5 times 10, but if you're converting from centimeters squared to millimeters squared, you would do 5.5 times 10 times 10 again, doing it twice for the area units. Okay, so 1 centimeter is 10 millimeters, so 1 centimeter squared would be 100 millimeters squared. You either double the zeros or you do 10 times 10 is 100. So just showing a few ways of doing that question. Okay. Now with the next one, we've got 5,625,000 meters squared to kilometers squared. If we're going from meters squared to kilometers squared, we will divide by a million. So that will be 5,625,000 divided by a million. And if you divide by a million, you'll get 5.625 kilometers squared. The other thing you can do, normally when you convert from meters to kilometers, you would divide by 1,000. So you can take this number, divide it by 1,000 and divide it by 1,000 again, so doing it twice. And with the last one here, millimeters squared to meters squared, we can see that we divide by 100. So it would be 75,000 divided by 100. And, millimeters squared to meters squared. Sorry, I've made a mistake. You would do divided by 100 and divided by 10,000. So 2 steps. So on your calculator, you can do 75,000, divide it by 100, you get 750. Divide that by 10,000, and you will get 0. Now you want to do this on your calculator. Dividing by 100 and dividing by 1,000, you get 0.075 meters squared. Okay, now for the last two questions with hectare conversions. So these conversions are given to you. So from kilometres squared to hectares, so that would be this conversion. So 1 kilometre squared is 100 hectares, so you will multiply by 100 to go from kilometres squared to hectares. 4.7 times 100 is 470 hectares. And the last one, to go from metres squared to hectares, so we're going from metres squared to hectares. The conversion is that 10,000 metres squared is 1 hectare. Notice there are more metres squared than hectares, so you would divide when you go from metres squared to hectares. And the conversion, what we divide by is by 10,000. So we see how many 10,000s go into 25,000, and we end up with 2.5. Okay, hectares. And that's the end of that pre-test solutions.